Continuing our Chapter 6, Exponential and Logarithmic Functions. We previously investigated exponential functions. In 6.4, we'll look at logarithmic functions. We'll start with an exponent exploration. Before we define a logarithm, see if you can follow the pattern below. Then try to fill in the missing pieces, A through F. So if we look at these logs that we're given here, and we're looking for a pattern. So the log to the base of 3 of 9 is 2. The log to the base 4 of 16 is 2. You're seeing a pattern here. Log base 9 of 3 is a half. Log base 3 of 27 is 3. You see a relationship between any of those numbers. Well, here we see that 3 squared would give us 9. Does that same pattern work? Is 4 squared 16? Yes. Is 9 to the 1/2 3? What is raising to the 1/2 power? That's the same as square root, right? And 3 cubed is 27. So what we're seeing is that the log is just an exponent. Every time we find the log here, we have found an exponent. So let's see if we can fill these in. For A, the question would be, right, 2 to what power would give us 8? This is the exponent. What would the exponent be? 3, right? And B, 4 to what power would give us 16? Of course, we just saw that one. That would be 2. Now this one we're looking for the base. The base is that small number telling us what base of log we're working with. So the question would be, what would we raise to the second power? What has an exponent of 2 that gives us 64? 8, yes. So this base is 8. So what raised to the third power would give us 64? Well, that would be 4. Okay, now we're looking for our argument of the log. So 2 to the 4th power would give us what? 16. And 4 to what power gives us 2? 4 to what power gives us 2? Right? You would take the square root of 4 to get 2, right? So that power would be 1/2. Okay, so let's pull this all together. Logarithms are just a power, an exponent. For example, log base 2 of 35 equals 5 says the logarithm with base 2 of 32 is 5. It means 2 to the 5th power is 32. Notice that in both logarithms and exponents, the same number is called the base. Okay, so when we're writing it up here, the base here was 3 for that exponent, right? It's also the base of the log. The base for this exponential expression is 4. It's the base of the log. That word base means the same thing in both forms. The logarithmic function with base A, where A is a positive number and not 1, is denoted by y equals the log to the base A of x. That's how we read that. And is defined by y equals log to the base A. That's a small subscript, right, of x, like this. That's true if and only if x equals a to the y. We're just writing it in the two different forms, just like we were doing up here, but using variables now. So notice that the y is the exponent. There's the exponent, and the log gives us an exponent, just like we did up there. Y is the exponent, a is the base. The domain of the logarithmic function is x is a positive number. It can't be 0, but any positive number. And the logarithmic function is the inverse of the exponential function that we just previously investigated, exponential functions. Logs and exponentials are inverses. To find the inverse of a function, we switch x and y. Okay, so let's continue. talking about that. Find the inverse of the log function. So we have the log function y equals the log to the base a of x, and that may be written as I shouldn't put this together. It's not maybe. May be written as, so the other way to write that was what? X equals a to the y. The y is the exponent, the a is the base. So these two are the same thing, just two different formats of the same thing as we saw on the previous page. We're going to find the inverse, so we're going to switch x and y. All right, so instead of x equals a to the y, we'll write y equals a to the x. Therefore, f of x equals the log to the base a of x has the inverse. The inverse of this log, and this is how we write it, f with a -1 as an x. It looks kind of like an exponent, but it's a superscript that we're labeling with. It's not an exponent. It's just a superscript to mean the inverse of f is equal to, what did we just say? What did we say y was equal to? A to the x, where x is the argument. That's what we call that, of the log. Okay, so we've shown how the format, and this is just what we saw previously, how the format of the inverse of the log just takes us back to 6.3 to our exponential.